Hello friends, welcome to my channel Nauroza's CAC tutorial. Hope you're all doing well. So last day I had discussed two examples of poset, and today on my lecture 3 part I am going to discuss some of the important features of poset. So let me start with comparable elements in a poset. Two elements A and B in a poset S less than equals to are said to be comparable if either A less than equals to B or B less than equals to A. Actually here this less than equals to sign is signifying the poset or the less than equals to. Actually these two signatures are very near, so that is why for a poset less than equals to sign is also used. So come to the example. Let S 1, 2, 3, 4 a set, then the two elements 2, 4 and B14 are non-comparable, cause here the poset is consist of 1, 2, 3, 4 and the relation is the subset. So 2, 4 and 1, 4 both are the subset of S. So the subset relation is the subset. So the two of these elements like A and B are non-comparable, cause the two elements A and B in a poset are said to be comparable if either A less than equals to B or B less than equals to A. But when both are true for a set, then that will be non-comparable. Now, totally ordered or linearly ordered set. A poset is less than equals to is called totally ordered set if every pair of elements in S is comparable. Like for any two elements A, B in S, either A less than equals to B or B less than equals to A. So if this is true, this condition is true, then the set will be totally ordered set, cause every pair of elements in S is comparable. And now coming to its examples, like the poset Z less than equals to is totally ordered set because any two integers A and B, either A less than equals to B or B less than equals to A, like a poset which is consist of integers and less than equals to. So for that poset, obviously for any two integers, either this true or this true. So that poset will be linearly ordered or totally ordered, cause any two elements of that set are comparable. And the poset PS and the relation is subset is not totally ordered, cause we know that a power set of a poset is consist of every subset of that poset. So if the power set consists of every subset of that poset, so any two elements of this power set will be non-comparable, cause both are belong to this PS or both are the subset of this PS, so they are non-comparable. So that is why this poset will be not totally ordered. Now, immediate predecessor and successor. Let S less than equals to be a poset, and suppose AB belongs to S. We say A is an immediate predecessor of B, or B is an immediate successor of A if A less than B and there is no element in C in S such that A less than C less than B. If A precedes B and S contains no element which lies between A and B, this is written as A less than B. Sometimes we say B covers A. I am starting with one of the most important topic of a poset, and that is hash diagram. So first let me go with the definition. Let S less than equals to be a finite poset. We place the points on a plane which represent the elements of S. If an element Y is an immediate successor of the element X, then we place Y higher than X and draw a line joining. Thus a diagram is created whose vertices represents the elements of S and edge represents the immediate predecessor or successor relationship. This diagram is known as hash diagram of the poset. Let me start with the first example to draw a hash diagram. Let S is consist of these elements. So S be a set and divisibility be a relation defined in S such that A by B means B is divisible by A, or A will divide B. So whenever the set is given, first we have to write it relation so we can check this relation is a poset or not, cause to draw a hash diagram we have to make sure the given set is a poset, cause then only we can draw a hash diagram. This is the relation of the given set. So we have to make sure this relation satisfy all the three conditions for a poset. So let me pick the first condition to be a poset, that is reflexive. So from the definition of reflexive condition, we come to know that the element will have relation with it, like with itself, like 1 is divided by 1, 2 is divided by 2, 3 is divided by 3, 4 is divided by 4, and so on. So this relation set is consist of the same element has relation with the same one. So this is reflexive. Then we will check the next condition to be a poset, and that is antisymmetric. Like here the set or the relation set consists of 1, 2, but 2, 1 is not there. If 2, 1 is there, then the relation will not be a poset, cause then it will be a symmetric relation. So 2, 1 is not there, cause 2 will like never divide 1. So that is why the antisymmetric condition has been satisfied. Now the next condition to be a poset, that is transitive, like 1 2 is there, then there will be 2 4. So 1 2 is there, and if there is 2 4, then 1 4 will be there. So 1 4 is here. So if 1 will divide 2 and 2 will divide 4, then 1 will definitely divide 4. So the third condition to be a poset, and that is transitive, has been checked. And now we will draw the hash diagram of the poset. So from the definition of hash diagram, we know first we will pick the first element of the poset. So that is 1, and we will give a vertex to 1. Then we will draw the second vertex, and that is 2, and then we will join these two vertices by an edge, as 1 will divide 2. So to show that relation, we will draw this edge. Then the next element is 3, and we will draw like the vertex 3, and we will join these two vertices to show the relation, like 1 will divide 3. Then the next element is 4. So we will draw the vertex 4. Then we will check the top elements, the last top elements. Like we always will check the last top element or elements, as there is any relation to the present vertex or not. So to check that, so 4, like 2 will divide 4. So we will draw an edge joining 2 to 4. Then we will check the another vertex, that is 3. So 3 cannot divide 4, so we will not join them. So then if 2 already can divide 4, then we will not go farther, like we will not go farther on the bottom side. Then we will check for the next element, like 6. So 3 will divide 6. Now 2 will also divide 6. Then we will join 2 to 6 and 3 to 6. Then we will pick the next element, that is 9. 9 will be divided by 3 only, because 8 can't divide 9, 6 can't divide 9, 4 can't divide 9. Only 3 will divide 9. So we will draw an edge joining these two vertices, like 3 and 9. Then we will pick the next element, that is 12. 12 will be divided by 6, and 6 on the same height there is 4, and 4 will also divide 12. So we will join 4 and 6 to the vertex 12. And then the 18. 9 will only divide 18, but there is also an element that will divide on the same height, that will divide 18, that is 6. So we will join these two vertices, 6 and 18, and 9 and 18. Then the next or the last element of this poset, that is 24, and 24 will be divided by 12. and on the same height there is 8, and 8 will also divide 24, so that is why we will draw both the edges to join 8 and 24 and to join 12 and 24. Now this is the complete hash diagram for the given poset. Hope I have made you clear the hash diagram, and on my next lecture I am coming with more examples on poset and hash diagram. Until then, please subscribe my channel and do like, comment if you have any query on my lecture sections, and also press the bell icon so whenever I upload any video you will be notified. Till then, thank you.